So now we want to create an interactive container. We are running still BusyBox, but now with TTY attached in an interactive mode. TTY is basically a terminal. Here, my iTerm application. And in BusyBox, we want to run a shell, a regular shell. So we do that here. And there you got a shell. Now, as you can see, this is not a Mac OS. It's a Linux, which means that my my local terminal has been bound to the container. And if we do docker container ls, you can also see that there's a BusyBox running here, the relaxed Bose with the following container ID. So containers can be interactive, which is rather nice because sometimes if, for example, building a container image doesn't work as you want, or starting a command doesn't work, you really want to get inside of that container with an interactive shell to figure out why and what is going on. If you ever use something like Cloud Foundry, where you don't have container images per default, but build packs, and you try to figure out why a build pack is failing, and all you have is logx is logs, then you know how frustrating this can be. So here you have more interactivity, and that is a good thing. Here my camera fails again. I have to cool down the camera. Okay, so interactive. We exit, the shell exits, and subsequently the container exits. So I could also Control D, that would also exit the shell and the container. So if we want to do something that takes a little bit more time and is detached, we use the -d flag. So this will do nothing but sleep for a while. So this has been detached. So I have my shell I have my shell back. And if I list the container, we have another BusyBox with another ID. This time it's sleeping for 10 minutes. Nordic Colden is the name. Now, in this case, I would like to execute a command within that particular container. So I use docker exec, which is different from run, because run runs a container and exec runs a command inside an existing container. I use the Nordi container, and I'm starting a shell, which brings me to that container. But is it the container I was looking for? And you can see it is the container because there's a sleep command. So you may have gathered the impression that once you start a container, you can't influence anything in it, because if you interrupt it, it will be terminated. But this is actually not the case. You can run it, and while it is running, you can basically log into it and run different commands using within the same container. And that's the purpose of docker exit. And you can also assume, because that's the case, I know that for sure, Kubernetes has a similar command, kubectl exec, where you can do basically the same thing. So it is possible to log into a container and run interactive or one-off command. So you could specify any other command despite of the shell. So the exec command would work for Azure hello without interactive. I mean, what's the purpose of this? We could maybe do that, and you could also see that this exec listed the process that's running here. So at some point, this container will shut down because sleep will terminate after 10 minutes, and then the container will subsequently shut down. So I can also use the ID to stop it, as we've seen before. I wanted to demonstrate something, so we'll create another one. Docker container ls. So there's another busybox sleeping. It's sweet Wilbur number 3. And we are creating a shell and we're on the root directory, yes. It doesn't matter actually. Or let's say we create a file called text, and it contains a string text. If we create another shell, we can see that the text file is here and it has its contents. So I can stop the session, I can start the session, and the file is still there because the container is still running. So here it is. But the time I stop the container, there is nothing like a start command. Well, there is a start command. Well, now the container is running. This can work. I didn't know that there was a start command. And it seems like there's persistency, which is very strange. All right, I have learned something new. The point is that the persistency is definitely not there if the container has failed in a way that it is not being restarted, which is usually not the case. For example, in the case of Kubernetes, containers will not be restarted. If containers are not restarted, then the contents of the container are definitely gone. So in that particular case, a container will be rescheduled and not restarted. We'll see that in Kubernetes when we do some experiments with Kubernetes, that a rescheduled container does not have that same persistency thing, which only works because it is on the same machine. But in a distributed cluster where containers are parts of pods and pods are rescheduled on arbitrary nodes decided by the scheduler, you don't have you cannot make the assumption that you will be on the same node, and definitely the container will not be restarted. Oh, but I really didn't know that this is even possible, and I mean, why should it? But all right, learned that lesson. That really destroys my next punchline, because in the Kubernetes example, when you create a container or a pod, so to say, the smallest unit you deal with is a pod. A pod may contain several containers, and the pod is terminated, then the contents are really gone. So there's a little video I linked in the tutorial. It's a little episode from South Park.
How can I help you, young man?
About banking.
I got a $100 check from my grandma, and my dad said I need to put it in the bank so it can grow over the years.
Well, that's fantastic. A really smart decision, young man. We can put that check in a money market mutual fund. Then we'll reinvest the earnings into foreign currency accounts with compounding interest, and it's gone.
What do you mean? I have $100.
Not anymore, you don't. Poof.
Well, what can I do to get back
I'm sorry, sir, but this line is for bank members only.
I just opened an account.
Do you have any money invested with this bank?
No, you just lost it all.
Then please stand aside for people who actually have money with us. Next, please.
Hey!
Hello, Mrs. Sparnickel. How are you today? Making a deposit, are we?
Yeah, I love it. So, poof, it's gone. Well, in this case, it's not gone, but you get the point. All right. So, if you do want to persist data beyond the existence of a single container, then you could use volumes to do that. But we'll come to volumes in the context of Kubernetes again. We don't use them, or we don't need them right here. All right. So, creating container images.